We're joined now by Dr. Deborah Ehichioya, who is a medical virologist and head of virology unit of the World Bank-funded African Center of Excellence for Genomics of Infectious Diseases. This is a long one, actually, of the Redeemers University. Morning. Thank you for coming on today.
Thank you for having me.
We understand it was in your, you were part of those who were able to work on the specimen from Mr. Sawyer. Tell us about that.
We got a call that there was a suspected patient in Lagos, and from the Lagos State University Teaching Hospital, actually the College of Medicine, Professor Milabu sent us the samples and said he's also working on it. We should also work on it. We've been collaborating over the years on the virus studies. So we got the sample, and of course we have this center already where we've started some research work on viruses or pathogens of interest in Nigeria right now. So we went ahead and immediately started testing. So we have various diagnostic tools which we use for different pathogens. But for this one, we actually use the polymerase chain reaction. It's actually a process where you look for a fragment of the gene or any segment of the genome from the virus. So you use short sequences of primers to target and prime specifically for this virus. So that's what we did. We did for the entire family, which is the Filoviridae, and we also targeted specifically the Zaire strain, which is known to be very pathogenic out of the 5 strains of Ebola that we have. So that's what we did, and we worked. We did the first assay was positive. The second, we had to do up to 4 because we really wanted to be sure. So by the 4th time at about 6 a.m. in the morning, we were sure this was really Ebola in our midst. So before we released, communicated with Professor Milabu, and the result was released.
How long did it take, to even get the first test result out?
Oh, it actually depends. You have to, first of all, inactivate the virus in some kind of detergent and salt solution, which we call lysis buffer, just to inactivate it and ensure you're safe working now with it on the open bed. So that was the first thing we did, and that took a little while because we really needed to be careful. So after that, we went directly, and between the first time we started from the safety cabinet to the first time the result was out, we'll say that took like 7 hours. So subsequently, we already had the genomic material from the virus, which is the RNA, and we just went ahead and did the rest, carried out the rest procedures. That took like 4-5 hours each. So but we had to run it simultaneously now because we knew what we were dealing with.
So you're talking about a span of, if you're looking at it in days, that is how many days?
No, I'm talking about hours.
Yes.
Yes.
So everything can be found out within a day. Is that what you're saying?
Yes, of course.
You can confirm that somebody has Ebola.
Of course, within a day. This polymerase chain reaction is even a longer process. We have shorter and more rapid processes that can do this detection.
Okay, Dr. Deborah was part of those who actually isolated and confirmed that Patrick Sawyer's case. One wonders, there's so many questions about all of this in terms of that sample. Is it the same thing? Okay, well, it said it's not because it has its period, the first 21 days. So if someone contracts it the first 2 days or the first day where the symptom is not so pronounced, what happens if someone touches that kind of person? Do you contract it as well?
Yeah, we have what we call the incubation period for every single infection. So once the infection sets in and is already replicated and multiplied in the system, definitely one will contract it if you have contact with body fluids. But this depends, the incubation period actually depends on each individual. For Ebola, we say it's between 2 days to 21 days. So it actually depends on the immune competence of whoever is infected. So if the immune competence is, if there's immune competence really high, then definitely the incubation period will be longer. But if the immunity is already compromised, of course, symptoms will start showing within 7 days. So infection would have set in right from the 2nd day after infection. So this actually depends on each individual. So definitely, once somebody gets infected and the virus is already replicating, definitely if anybody comes in contact with this person, the person will get infected. So it depends on how much immunity this person has garnered over the years.
When you say replicating, how long does that take?
for bacteria is very short. For viruses, it's also very short, even at times shorter than bacteria.
So if one comes in contact with it, like in 5 minutes, it could have replicated?
No, like between 6 and 18 hours. It would have started replicating and circulating. Of course, the circulation system takes it all over the body, and you start having it in body fluids. But first of all, you find it in blood, then saliva, and maybe semen, and every other kind of body fluid. At times, sweat for some viruses.
How quickly, I mean, how soon can you test an individual to say that this person has contracted the Ebola virus?
This also depends on the immune competence of the person. So within 2 days, you can already see viremia, that is viruses in blood stream. Also, for others that immunity is already compromised, you can see it even less than that. So this actually depends on each individual. But what is very important is if anybody has come in contact with somebody that is confirmed to have Ebola, then surveillance should start immediately. So you can actually start taking blood at intervals and already start checking. So at times you see very low rates of viremia in the fluid. At times you see it increasing. So you have to check. At times you're also treating, if you have specific antiviral medication, you can also see a drop. So you can actually monitor how the viral load rises in the body and how it drops.
So when we say that
viral infection.
Sorry to interrupt you, but when you say that they're quarantined, they're not just isolated and being watched and given food and water and that, they're also being tested.
They should be tested.
Constantly?
Yes, they should be tested. If somebody is already confirmed to have the virus, you isolate this person. And you also, if you're treating, giving supportive medication, you should also test constantly to see if the viral load is increasing or is reducing. Then, if somebody is also quarantined and perhaps already has fever, you should also check if the person has viremia at all. So if the fever subsides, you can decide, depending on the resources or the capacity of your lab, to stop testing or increase the interval between tests. So this actually depends on the resources you have. So, but ideally, once you quarantine, you keep monitoring the temperature and watch for symptoms. If temperature increases at all, then you start doing lab testing.
Besides talking about resources, Chamberlain, you talked about Dr. Melabu's facility. Besides that facility, do we have any other facilities in country for testing? Besides yours as well?
Ebola virus is actually a level 4 pathogen. When I say level 4, there are 4 levels of pathogen we have, from level 1, which is the least, to level 4, which is the highest. So in Ira, in Edo State, we actually have a facility in the specialist teaching hospital that also tests for a similar virus called the Lassa virus. And that we already are familiar with in Nigeria because we've had a series of outbreaks in Nigeria. So that facility has been upgraded over the years and also designated a center of excellence for Lassa fever detection. They can also be upgraded to do this testing.
Okay, now the Lassa fever and the Ebola virus.
Ebola virus, yeah.
Is it the same process of testing?
It's the same process of testing. You can use the same process. You can test for antibodies in people that are infected. You can also go directly to test for the presence of the virus. But of course, you have to use different primers, different sequences, because these sequences are specific to the gene, a fragment of the genome, specifically for this virus. So you have to use different primers, which are short sequences of complementary nucleotide sequence for this virus. So the same process, but the tools and the reagents you use might vary a little bit.
There's some very technical stuff that you're sharing with us this morning, but I'm sure that, you know, the medical personnel who will be listening to you will definitely be gaining a lot from what it is that you're saying. But, you know, you talked about immunity, the level of immunity, being able to combat or showing that it might take a while if your immunity level is high. What can you tell us about, can one ever combat the virus via the person's own immunity?
Yes, our immune system is actually built to be defensive against any antigen, any foreign or invading invading pathogens to the system. That's how our immunity should work if it's competent and not compromised. So what actually happens is that once your body recognizes and is able to recognize an invader or an antigen or a part of this pathogen, it mounts some kind of resistance and immunity. And most times you also can detect this in fluid. So this is what we call the antibodies. So these antibodies actually protect other cells from being invaded too by these organisms, and also tend to react specifically with this antigen. So it binds to it, and the immune system or your immunity has a way of engulfing and pushing these pathogens out of the system or destroying them completely. So the immunity actually has a great role to play. And when we take immunization or vaccination, this is actually what we are doing. We are priming our immune system. We are telling it to recognize this pathogen. But what we do, you introduce something that is not as pathogenic as what the real organism is. So you attenuate it or you inactivate it in a way. So you already introduce it to the system. So the system is used to this pathogen and can already mount defense in preparation for when you actually come in contact with the real pathogen. So you already have antibodies in the system is ready, is used to it, and it can recognize this pathogen when you come in contact with it in the wild. That's actually what vaccination does.
Okay.